Hey, so this will be part two of my SNMP 101 series. I guess I'll call this one SNMP 102. This one will be a little more interesting in that I'm not going to go into all of the under the hood details of how SNMP works. We're just going to talk about some different ways of using it. So this is a program called Cacti. It's actually a really old PHP program. I've got a very old version. I haven't upgraded in ages, but the idea is that you can teach it how to monitor different types of data. Out of the box, it knows how to do SNMP queries, which is great. You can tell it to monitor interfaces on servers and switches and routers, and it just out of the box knows how to do it. It'll monitor traffic stats, it'll monitor error rates on ports, all of that sort of thing. But you can teach it how to do other stuff. So for instance, here you can see I'm looking at my development logger system, and I'm graphing the number of logged in users and the number of processes running. This came from the host MIB. Here's the traffic stats that came from MIB2. Then I'm looking at file systems. So you can see I have two file systems here, and the data file system, whenever I truncate throw away some of the old data, you see the data usage will drop. And then we've got CPU usage. This is all coming from net-snmp. So you can see this one has 2 CPU cores, which is why the graph goes from 0 to 200. And the idle trace is not 200 because we've got some CPU usage. So the blue is going to be the syslog daemon and Elasticsearch. The red will be the operating system, it's the kernel. And this little thin yellow line is IO weight, which is agreeably low. That spike is probably from the backups running. And there's a big spike in traffic. This is Ethernet. Oh, I'm sorry, this is disk traffic. So yeah, that would have been the backups running. You can see a big spike in reads. And there's the load average and memory usage, the number of SSHD processes running. These are all things you can configure these are all things you can monitor using net-snmp. Which processes you want to monitor the number of and the maximum of is configurable in net-snmp. So in this case, I just have told it that I want to monitor SSHD, the number of them. And then we can monitor paging activity, swap activity, and swap usage, and these are agreeably 0. Paging activity, you want to take with a grain of salt. This may not be a memory issue, so in this case I know it's not a memory issue. A lot of database servers use the paging subsystem to do their disk I/O. It's the fastest way on a Unix or Linux server to do disk I/O. Basically what you do is you map a big file directly into memory. That's just the page refreshing. And then you just access that file as if it were memory, and the paging system, the operating system, takes care of doing the disk I/O. Anyway, that's a long way of saying database servers, sometimes when they're doing their I/O, it shows up as paging activity, and that doesn't necessarily mean that you're running out of memory. Swap activity, though, if you see swap activity, then you're definitely running out of memory. So anyway, how did I teach Cacti about all of these different things? If we go to the console, we look at data templates, and we do a search for, let's search for CPU. So you can see I've got a whole slew of different things. I've got some things that I pull via a script, and most things I pull just via get SNMP data. So for instance here you can see I'm getting the CPU usage from a Juniper device, and I'm using get SNMP data to do that. Same with Barracuda's fans, or Barracuda spam firewalls. I'm looking at the CPU fan. But let's look at UCDNet. Let's look at the idle trace. So here you can see I'm telling it I want to fetch it via SNMP. I'm going to call it the name of the data source is going to be CPU usage idle. And internally, the name of this data source is going to be CPU underscore idle. That'll be important when you start making graph templates. And I want the maximum value to be 100 by default. But notice that I've got this checked to be use per data source. That's because well, I'll tell you about that in a minute. And more importantly, I'm telling it that it's a counter. You remember when we were looking at the CPU counters in Scotty or TKMIB, the CPU counters, they were 32-bit counters, and they were great big numbers. And the way you measure those values, remember, is not just by fetching the value and graphing it. You have to fetch the value, wait a certain amount of time, say 5 minutes in the case of cacti, fetch the value again, subtract the two, subtract the first value from the second value, and then divide that by the number of seconds in between those two fetches. Well, the cool thing is that cacti does all that for you. If you tell it it's a counter, it'll do all that for you. So then we come down here. This is the SNMP MIBoid for the idle CPU counter. And again, you can get to that just by browsing through TKMIB or using Scotty. Browse down through the private enterprises, UCD SNMP, and I forget the full path, but look at my previous video. You can watch me browse down to it, and then eventually you find the CPU idle counter. So notice that it's 2021, that's UC Davis, an 11, and I don't recall that system performance, I think, something like that. 53 is the idle counter, and there's a .0. It turns out that the way net-snmp is implemented, no matter how many CPU cores you have, there's only one idle counter, and it always has this .0 appended to it. So 53 is idle. Let's cancel that and look at UCDnet interrupt. And that one's 56. And we can look at user. And that one's 50. So if you go browse to the MIB tree, you'll see all of these show up in there. These are all the different CPU counters that we can fetch. Well, most of them. I think there's actually one or two new ones. But so once and we've named them all. So this one is CPU underscore user. Once you've told cacti about these data templates and how to fetch them, what OID to fetch that data at, and what type of SNMP value it is. In this case, it's a counter, just like a traffic counter. Then you can go into graph templates, and let's go to net-snmp CPU usage for Linux. And here's the graph template. So here you can see the data sources that we defined in the data templates. And here's basically telling cacti I want to do an area at the bottom of the graph for red is system, and then next I want to stack on top of it an area graph for IO wait, then user, then nice, and these are the colors that I want to use for those different CPU values. And then finally we have a line in black at the very top that's, well, hopefully at the top, that is the idle counter. And the way net-snmp has implemented these CPU counters, if you have 16 CPU cores and the system is idle, if you take the idle, well, assuming the system is idle, if you fetch this and it'll be from 0 to 1600. So if the system is idle, this value, the idle data, the data that you fetch with that data template will be 1600. The aggregate of all of these, the delta of all of these counters added together will be 1600 because you have 16 CPU cores. Now that's different from the host MIB. When I'm monitoring Windows systems and I'm using the host MIB to fetch their CPU counters, they don't really have CPU counters. What they have are a gauge. It's just a number from 0 to 100, and they'll have one of those for every CPU core. So in the case of a Windows CPU, you'll notice that I use a totally different, I think I've got this in here. Yeah. So I've got to make a separate graph template depending on how many CPU cores the Windows system has, because instead of having counters for each of the different types of CPU usage, I have a gauge for every CPU core, and that's just the way Windows has implemented their host MIB in their SNMP daemon. So anyway, that's the way you can teach cacti about all these cool different data sources, and then depending on what type of system it is, you can do all sorts of different graphs. So another good example would be, let's look at, instead of a server, let's look at a SAN switch. So if I go to, say, a Brocade switch, and now you can see that I have set up data templates and graph templates for these brocades. So different brocades have different numbers of sensors, of temperature sensors, and I've given it the SNMP OIDs for each of the different sensors, and then made a graph template for the different flavors of brocades, so that I can then put on those graph templates the right temperature sensors or fan speeds. The brocades automatically will let you monitor their SAN ports as if they were 64-bit Ethernet ports, or 64-bit counters on their Ethernet ports. So you can just monitor it like a regular old switch or router. But you can also, and I think that's what these are. Yeah, these are error rates. I took the SNMP OIDs for the error rates, the different types of errors that you would get on a SAN port, and I made data templates for that, and then I made graph templates. So now we can look at the error rates on different ports. Some of the errors they're like congestion in an Ethernet switch. They're not a big deal, it just means that the switch is busy or that port is busy. But you get the idea. So that's what I was getting at in the first video. This is why SNMP is cool. You can monitor from one system, one monitoring tool, a wide variety of different hardware, whether it's a Brocade switch or a SAN fabric switch or an Ethernet switch. It doesn't matter. As long as it supports SNMP, you can teach it. You can teach your software how to monitor that device, how to get interesting stats from that device. So another tool that I use a lot is Nagios. And again, this is an old version, but it's a very old version actually. But we've written a variety of plugins, and I've downloaded a variety of plugins that make this a really useful tool. So I made one called Check System Performance, and it uses SNMP to fetch performance stats from net-snmpd. And you can see that looks very similar to the cacti graphs. What happens is when you have a plugin that returns what Nagios calls performance data, Nagios makes note of that data. This is the performance, here's the performance data. And if your plugin supports that, in addition to writing it here in your Nagios web interface, which is interesting but not really all that useful, if you have an add-on called PNP for Nagios that adds these little icons here, or like the one I showed you a moment ago. And PNP for Nagios takes the performance data and makes an RRD graph, the same as cacti does. So pretty cool. This one, the way the plugin was written, it always returns a value between 0 and 100, no matter how many CPU cores it is, good and bad. I don't recall the technical reasons for why I did it that way. That was the easiest way to feed it into Nagios. And it means that now I can have one Nagios service check that works on any Linux system, any HPUX system, any IRIX system, any system that's running net-snmp. So in this case, it works on most Linux-based appliances too. I can fetch the CPU stats for our Barracuda spam firewalls this way as well. And I'm getting load averages and things like that. The same sort of things that I'm fetching with Cacti, I'm fetching with this SNMP plugin. And here you can see we're monitoring some Arista switches as well. And we're getting the same kind of thing. We're looking at traffic stats, and we're also looking at the environment sensors and making sure that all the sensors are okay. We're fetching a wide variety of sensors. You can see that there's a ton of different sensors on those switches. And let's take a peek at the nagios config. So here's the service check where I define it. You can see that I'm calling the same command, this check entity sensors. This plugin uses the entity MIB that I talked about in the first video. And you can see that I'm applying it to both Arista switches and Mellanox switches. So whenever possible, I'll use this same plugin as long as the device supports the entity MIB, part of the MIB2 tree. Then I can monitor its chassis stats with the same plugin. I don't have to make a new plugin. But if I need to make a new plugin, it's not a big deal. In fact, let's take a look at the check entity plugin. So here you can see I just defined the base MIBoid of the description table and the sensor table. And then I tell it about some other MIBoids for some specific things, the value, the status, the units, and the precision. And that's how then the plugin can figure out this particular server or this particular device has this many power supplies and that many fans and temperature sensors. A different device would have a different number of power supplies or a different number of fans, or it might not have any temperature sensors. But the plugin figures that out. It monitors what it can monitor, and that's the nice thing about the entity MIB. If the device supports it, use it. If not, then you can take this plugin and modify it and make it specific to a Juniper or make it specific to a Cisco, whatever your needs are. And feel free to, I've got a whole ton of plugins on the Nagios Exchange website. Just search for SGICHK and you'll find a whole slew that I've written for a variety of devices. Most of them are SNMP based because it's simple.